Hello, this is going to be a video showcasing and going over a bit of the technology behind my custom designed controller that takes DMX input from a lighting console and converts it into RGB Strip data protocol. This one specifically has been designed to run the Govee RGB Strip Pro 2, which is a very high quality strip light that has not only red, green, and blue channels, but also has a dedicated cold white and a dedicated warm white LED. And the reason I have designed it specifically for this is this allows you to have a very high quality color control on your light in a very cheap package. I think you can buy the 1 meter long sections for about $20 each. And compared to other meter long DMX LED bars, this is usually over half the price. The only caveat to that is you will need a controller, which will be a little more expensive. But if you're using one controller, you can control up to 10 strips of RGB. So here on the floor, I have a demonstration setup using 2 segments. And unfortunately, I only own 2 segments at the moment. I have 2 more on the way for testing purposes. But so far it's been working quite well with 2 of the segments. 2 segments makes about 2 meters of length. Actually, it makes exactly 2 meters of length. And all 10 segments will get you 10 meters of length. Each segment has 10 color zones on it, and each of those 10 color zones have 5 DMX channels. So 1 meter of this, if you're using it in the full resolution capability, is going to be about 50 DMX channels. So across the floor here, I have 100 DMX channels. It's also worth noting this is a prototype. This is an older board that I designed and had fabricated quite a bit ago. I think it was in mid-2025 when I first made these. The main improvement with this strip is software based, but due to that there are some limitations and there are a few bugs that I'd like to go over. So the first limitation is this is based on the Atmega 328P chip, which is a very somewhat old nowadays ARM chip, and because of that it's not really able to process multiple core instructions very easily. It only has 1 CPU core, so as a result this display is not really able to run with the data being updated on the strip. So because of that, I've just disabled the screen whenever the DMX is plugged in. Final design will, of course, likely have either a second chip dedicated to the screen, or I might even switch to like an ESP32 chip or something with multiple cores that can run everything a lot smoother. Another limitation is the DMX and the WS2811 protocol conflict with each other. I found that the best way to make it look smoothest is to allow the DMX to interrupt the fast LED push rather than having the fast LED push interrupt the DMX. I found that if it has a good DMX read, if it corrupts like 1 frame on 1 segment, it'll very quickly fix the frame. So you only really see 1 segment be the wrong color for about 1 frame. It's also only really noticeable when you're running a strobe on the strip from 0 to max brightness very quickly. And I know it's on the fast LED side, not the DMX side, because when I set it up to run only on 1 group of 5 DMX channels, it still has the tearing issue. So I'm hoping that can be prevented in the future with a better chip as well. So going over the front display of this prototype board, the final version will also end up looking pretty similar to this. It has 4 potentiometer knobs, and the reason I used potentiometer knobs is I didn't really want to waste processor time storing the values to the EEPROM. So this way it kind of makes it very easy to save the data when it loses power, because the potentiometer is physically in the same spot. So whenever the module boots, it pulls the data from the potentiometer, and since power loss doesn't move it, it'll keep the correct data address. It won't forget. So the first 3 knobs on the right side are for each digit of the address. So this is the 1's place, the 10's place, and then your 100's place. And it also has logic to where It cannot go past 512, and it cannot go below 1, like that. And then the fourth potentiometer on the other side is actually an adjustment for how many DMX channels you want to use. So this gives you a length adjustment, which controls the length of each section. So since this is on 2, it's now going to use 5 DMX channels to go across 2 segments rather than 1 segment. And you can go all the way up in somewhat even increments to all, which will control the whole strip with only 5 DMX channels. And now because of the first limitation, when you plug the DMX in, it will kill the display. And then you'll have this little DMX connection light turn on if it would focus. Focus, please. So yeah, there's a little DMX Con indicator, which shows that it has active DMX connection. In the final design, I still will have the screen turn off, but I will make it that if you update anything, it'll come back on for a couple seconds so that you can see what you're changing. Unfortunately, since it's limited, I have to disable the screen when there's DMX coming in. Alrighty, so the first functionality I want to show is the length adjustment. So this is my MA2 on PC wing, and I'm running Grand MA2. So this is a standard console that a lot of people use, and I'm going to show that this module works perfectly on it. So I'm going to turn this slider on, and you'll see it has a test pattern on the strip. What it is just every single channel is alternating from red to blue. And then I also have this pattern I can run on it to show that it is continuous channels and not just 2. So yeah. Now, even though the display is off, all of the adjustments still work live. So if I turn the size adjustment, as you can see, the segments become too long. Or I guess I should say the control becomes 2 segments long. So right off the bat, we have the amount of DMX channels being used. So as you can see, across the whole strip, it's now 2 wide. And instead of 100 channels, it's now using only 50 channels. And now this increases linearly for the first bit. So we can go from 2 to 3. And then we can go from 3 to 4. 4 to 5. 5 is a nice number because it divides each additional length in half. And then we can do 6. And then 7. And then after 7, I just made it jump to 10. So 10 is going to just be each segment is its own individually controllable section. And then after that, there is some that I won't be able to show because I don't have enough RGB, but this is 20. Actually, no, sorry, this is 15. So you can barely see it. So every 1.5 length of strip is its own controllable zone. And then this is where you can't see it anymore. This is 20, so every 2 would be its own. And then there's a 40, which is every 4. A 50, which is half of them are one, half of them are the other, and then a full. And full means no matter what, the entire length of the run will only be 1 color. Alrighty, so the next functionality I want to show is that it is using all 5 colors. So on the screen I have the red, green, blue, warm white, and cool white channel pulled up for all of the segments. And I also have that same sweep pattern running on it. So first, if we bring up the red channel, you can see all the segments are still doing a sweep effect, and it's red. The green channel, the blue channel, and then the 2 channels that make it worth using this strip. This is a warm white dedicated LED and a cold white dedicated LED. Having control over the color temperature is a very useful feature in a lot of lighting design. My mouse just died, because why wouldn't it? Hold please. So yeah, those are basically the key features shown. The reason this is very nice is almost like I don't think I can find another RGB strip on the market that has these dedicated whites, besides these Govee branded ones. So that leads me to another very difficult thing I had to overcome to get this working. Govee actually tried to make it so that people like me couldn't do this. They encrypted every fourth LED on the strip. So it's pretty silly, but each color has a fine and a coarse channel, but it's not for more resolution. It's just to make it difficult to make it do the full ramp correctly. So I actually had to de-encrypt it, and then they also made it do 4 different encryptions. So the first color has 1 encryption, second has a second encryption, third is the third encryption, fourth is the fourth encryption, and thankfully it loops till the end of that. So I'll show you kind of the code a little bit. So if I scroll down here and find the encryption sub loops. So like this is like the first one. Basically what they did is they made, when you go from 0 to 255 on the coarse input, it ramps 4 times. And this one, it goes even faster than that. So every 0 to 32 is 4 ramps. And then each ramp gets brighter and brighter. And then you have to like use switch statements to select the first complete ramp, then the second half of the second ramp, and then the second half of the fourth ramp. The third ramp isn't even used. So that's a pain. First, second, and third encryption both work in that principle, just with a different range here. But then the fourth one kind of threw me for a loop because they switched it up. This time the coarse channel does go a smooth 0 to 255, but it doesn't get as bright as the other ones. So then I found out there's a switch pin that boosts the coarse pin to the 4 ramps. So that it's basically the same exact principle, just a different way of activating it. So you go from 0 to 255, and then you go from 127 to 255, and then 127 to 255 on the coarse channel. And while it's doing that, the switch starts at 0, goes to 1, and then jumps to 3. And that, in effect, shows the entire ramp of colors. So just figuring that out alone is pretty huge. I'm sure there's a lot more capabilities for people now. I don't know if you could get this working with WLED, since it's not standard RGB. Like, I can pull up my spreadsheet here. Like, I can pull up this spreadsheet which shows what each segment is. So like WS2811 protocol, you know, it's in groups of 3. So this would be like 1 RGB, another RGB, a third RGB, a fourth RGB. But then Govee went and did this, where the first 2 overall are both for the green, red, blue, white, and then they just skip 1 entirely. It's a huge pain. It was very difficult to get this working. And because of that, it also puts a lot more computing stress on the ARM chip, because rather than having, you know, 1 protocol LED for red, green, and blue, you need like 3 entire protocol LEDs. So essentially, the chip on the module thinks there's like 375 RGBs, when in reality there's only, I think it's it would be considered 100 LEDs for the full 10 meters, and then each LED would have 5 sub-segments, so it's way less than 375. It just sucks that the computer has to process all this information just because they wanted to encrypt it. Like if they used the fine and coarse values to get like a nice, 16-bit control, it would make sense. But they're literally just doing it to encrypt it. So it's still 8-bit control, just split across 2 channels to make it hard to reverse engineer. All right, then after the ramps were decrypted, it's actually very common with RGB strips that the dimmer range is not color accurate. So that's what these 2 arrays are. These are just manual color correction throughout the dimmer curve, which makes it so that when it dims up and down, it still stays the same color. So like this is mixed white with the RGB, and it's not perfect. Like it especially shows up on camera that it's not perfect, but in real life it's very less noticeable. But from 0 all the way to 100, it stays roughly the same shade of white. And when you do that, it guarantees that when you mix any color, it'll roughly stay the same color from the dimmest value to the highest value, which is very useful when you're programming, so you don't have to try and counteract that with the lighting console. So that's pretty much all of the software features that I had to implement to get this to work nicely. All right, now I'm going to showcase the bug. So I have all the lights selected, and I'm going to put a very fast strobe on them. And you'll see like there's one. Every so often, a segment will drop a subcolor. Now this wouldn't even be noticeable if you're using like only blue or only green. It's just the way the strip is updating. Whenever the DMX is red, it'll corrupt a few subframes, and it will mess it up. So I can also show by putting this to all. It's only reading 5 DMX channels, but there's still that same tearing going across the strip. It's just kind of a limitation with the chip I used. Honestly, in most cases, you won't really even notice this, but I will try to fix it before I make a full production unit. The error, see if I make it red, it's really not noticeable. Let me stomp this. It's also sometimes slightly noticeable on a effect running like this. If it's going fast enough though, that's the exception. If I go in here and increase the speed a little, you'll also see occasionally there'll be a dropped frame. Let me actually make it even more noticeable by putting the width down. I guess it's not wanting to do it. You can't, there was one. It also just it could just be the refresh rate in general. Cause it's actually completely missing that segment there when it's going across fast. So it's really only noticeable under extreme cases. I have noticed it a few times when I'm dimming on and off slowly, but yeah, there's one there. But it's only when it's dim, from 0, dimming slowly. So realistically, you wouldn't really notice that. But it's still worth noting that there are a few issues with it. And unfortunately, these can't really be solved unless I switch to a more powerful chip. Yeah, there was another one there. It's if you manually strobe it too, you'll get a few color screw-ups. But for normal use, it's really not that noticeable, because since these have a dedicated white, you're really never even going to need to mix white. It's actually somewhat silly to mix white when you have a dedicated white. If I go to this swatch book, now it's just using the dedicated white. And you'll never really notice if a frame is dropped because it's just one color. So yeah, if you made it this far, thanks for watching. I'll try to keep this updated in the description. based on what my next steps are. So right off the bat, I actually have 2 more segments in the mail that I'm going to connect for and make sure that there's no severe issues down the line. At some point, I do want to get all 10. It's just they're $20 each segment, which is kind of expensive. But yeah, hopefully you'll hear from me soon. And if you're interested in buying a module like this, please let me know in the comments. And I will do my best to get this done as quick as possible. I am a full-time electrical engineering student at the University of Nevada, Reno, which takes up quite a bit of time. But yeah, this is kind of my hobby project, and I'm glad you guys enjoyed it. So thank you for watching. Have a great day.